readings. In this video I will start with the description of the prototype that I have made for the currently contest, named Continuously Powered Vacuum Generator for the TechMaster event. As part of this challenge, I took three main cues, which are the DC power for the prototype, which is okay, the vacuum generator, which is not easy but also okay, it can be done, and the last one, compact. But how compact is compact enough for this prototype? Well, a little bit of inspiration. I thought about this prototype like a new tool or a modification of an already tool. Like for instance, we can find the vacuum during soldering of electronics, or even in robotics we can find it as a tool for transportation of different objects, or also on the mounting of electronic parts such as SMD components within a PCB. So then, as inspiration, I took all these kind of vacuum generators from soldering, robotics, electronics, among others, to design the Vacc-Pen. The Vacc-Pen is based on a vacuum pump. This vacuum pump is from the manufacturer Nash, and I like the design of the turbines and the chamber, which is something not too hard to replicate. So I took some ideas from here, but I scale up a little bit, make it smaller and with a low cost scale. Then we 3D designed and printed turbine chamber, chamber cap, and a base for the portable electronic. But again, how compact is compact enough? Well, we thought that something portable, it is more suitable to use in electronics or robotics. Therefore, I took like a risk leap on it, and I took like 1 and 10 cents coins. Seems to be fair enough to get a turbine. So here we can see the three main parts, which is the 3D printed chamber, the 3D printed cover, the 3D printed turbine, and in comparison we can see the two coins, one of 10 cents and one of 1 cent. And finally, a DC motor took from a drone, which has a speed up to 65,000 RPMs. Then with all that, we made our first assemble. We can see here at left where it's gonna make the vacuum entrance, making this suction of air and pushing it to an output or to an exit. And here we can see like the first test with open chamber, with the turbine working, just in order to see how it works and how it flows the gas. The final assembly, we can check it here. We add the electronics, which is basically a switch and an indicator. From this first prototype, we have observed some accomplishments. We have accomplished that it is portable with only a 3.7 volts battery. The electronics are simple and compact because it's only to activate the motor. The input and output generates a constant airflow as we have thought at the chamber with the turbine. But also we have found pending improvements for a prototype, for a second prototype. The motor speed is too high and needs to be controlled in order to make it like in a slope from slower to higher speed. We have found some leaks of pressure in the chamber. That's the reason that it's not completely working, making a vacuum, among others. Then in order to make a better control of speed, also the electronics needs to be a little bit complicated. Thanks a lot for your time, and I have learned a lot with this challenge. Ciao.